Welcome to the Explainer. I want you to picture a scene from the Persian Gulf. It's December 2025, and Operation Epic Fury is in full swing. Somewhere off the Iranian coastline, there's this highly controversial trimaran warship, and it is just cutting through the water at 40 knots. Suddenly, a rocket booster ignites right there on its flight deck, and a small delta-wing drone punches into the sky. Then a second one launches, then a third, and within minutes, an entire swarm is airborne, heading straight into a deadly, highly defended war zone. But here is the massive paradox that we are going to unpack in our deep dive today. This historic moment, the very first time the United States Navy deployed a cheap, expendable attack drone swarm in actual combat, it happened from the deck of a broken ship that our own military literally tried to throw away.
To understand how crazy this is, look at this quote. Admiral Mike Gilday, the Chief of Naval Operations, called it the most challenging engineering problem that we have seen on any class of ship since I have been in the Navy. He was talking about the Littoral Combat Ship, or the LCS for short. You might know it better by the nickname the media routinely gave it, the Pentagon's floating garbage. The Freedom-class variant had this propulsion system where the torque loads literally ground the gear teeth into metal dust while the ship was underway. And the Independence-class variant, it had an aluminum hull that suffered from extreme metal fatigue. It was basically tearing itself apart with structural cracks just from the relentless cyclic stress of everyday ocean waves. Our own Navy was decommissioning some of these ships before they even reached half of their design service life. It was widely considered a total, irredeemable failure. But it still had a job to do.
So here is our agenda for today. We'll look at the broken ship's mission, step inside the kill zone, explore when failures become features, look at reversing the cost curve, break down Operation Epic Fury, and finally discuss math over perfect machines. Let's get right into it.
Section 1. The broken ship's mission.
So during the opening hours of Operation Epic Fury, this incredibly visceral scene played out. We had our massive $13 billion supercarriers, but they were sitting safely out in deep water. We had our highly advanced Aegis destroyers, but they were strictly holding the outer perimeter. And yet there was this broken, cracking, aluminum littoral combat ship right inside the cage. It was out there executing a mission that no other platform in our fleet could even touch. It was sitting right on the front lines, launching these cheap delta-wing drone swarms directly into Iranian airspace. Now you have to ask yourself, why on earth would Central Command hand the most crucial warfighting role to a platform with self-destructing gearboxes and a tearing hull? Well, the answer doesn't actually live inside the ship itself. It lives on the map.
Section 2. Inside the kill zone.
The Strait of Hormuz is, quite frankly, a terrifying three-dimensional kill zone. We are talking about a geographical bottleneck that is 21 nautical miles at its narrowest, but the actual usable shipping lanes, those are compressed into a tiny 4 nautical mile keyhole. And yet 20% of the world's crude oil passes through here. Iran spent 40 years turning this exact spot into a highly engineered anti-access architecture. Just look at the layers here. On the seafloor, you have thousands of naval mines, including these EM-52 rocket-propelled mines that literally launch upward into a passing hull. In the acoustic clutter of the shallows, over 20 Jadir-class midget submarines are lurking silently. Up on the surface, there are over 1,500 IRGC fast attack craft fueled up and ready to swarm. And then in the air, you have massive drone swarms acting as radar clutter just to hide their incoming Mach 3 ballistic missiles. It is an absolute nightmare scenario.
Because of all those threats, our absolute best ships were entirely mathematically unviable here. Think about it. A supercarrier costs $15 million a day to operate. It displaces 100,000 tons and holds 5,000 sailors. If you try to push that massive target into the narrow bathtub of the Strait of Hormuz, the physical constraint of distance immediately becomes your enemy. The time it takes for a multi-billion-dollar Aegis combat system to detect a threat, classify it, authorize a response, and actually fire, that whole process is actually longer than the flight time of an enemy weapon trying to reach us at that incredibly close range. Our destroyers are amazing platforms for sure, but every single vertical launch cell they carry is just far too valuable to risk inside that dense kill zone. So, by process of elimination, that leaves the Littoral Combat Ship. It has a small radar footprint, a shallow draft, high speed, and most importantly, it is highly expendable. It was literally the only option we had that physically and economically fit inside the cage.
Section 3. When failures become features.
Okay, so how did a ship that was literally tearing itself apart actually pull this job off? Well, through an incredible engineering paradox. You see, the LCS was originally designed around swappable mission modules. These were supposed to be these genius plug-and-play packages for anti-submarine or surface warfare, but that modularity concept was a complete and utter failure. They were notoriously late, wildly over budget, and severely underperforming. So the Navy threw in the towel, abandoned the modules, and just entirely stripped them out of the hole. But here's the crazy part. When you strip those failed modules out, look at what gets left behind. An 11,000 square foot, unobstructed, open architecture flight deck. We're talking roughly the footprint of 3 tennis courts sitting right there on a relatively small ship. That beautifully empty deck wasn't purposefully designed to be a feature at all. It was just left behind by failure. But failure accidentally left behind exactly what the Navy needed to bolt on a massive rocket-assisted drone launcher.
And get this, the second major failure actually saved the mission too. The Independence-class LCS uses a trimaran design, which means 3 narrow hulls spread far apart. Now, this is the exact design choice that caused that terrible metal fatigue and structural cracking under everyday ocean stress. It was a flaw. But that wide stance geometry also produced something else, a massive metacentric height. Think of the difference between trying to stand up in a really tippy canoe versus standing on a wide catamaran. The wider the stance, the harder it is to tip over. Now, while this is largely irrelevant for a traditional warship that's just launching vertical missiles, if you are a platform that needs to launch massive swarms of winged drones from your deck while sitting in open ocean swells, it is absolutely everything. The widely spread, cracking tri-hull inadvertently created a perfectly flat, incredibly stable table in a moving sea. It was the perfect launch pad.
Section 4. Reversing the cost curve.
Now, I want you to meet the weapon that completely changed the game out there. It's called the LUCAS, which stands for Low-Cost Unmanned Combat Attack System. And you guys, this thing is an engineering masterpiece built on a massive irony. The airframe is actually reverse-engineered from Iran's very own Shahed 136 attack drone. American engineers out at Spectre Works in Arizona meticulously studied the cheap aerodynamics and the operational range of the Iranian design, and they kept the physics that worked. But then they aggressively upgraded everything else. They swapped out the loud original engine for a super quiet DA-215 two-stroke engine, which makes it incredibly hard to detect by sound alone. Then they added a continuous Starlink satellite uplink to solve the radar horizon problem and allow human-in-the-loop targeting from literally anywhere on Earth. And most impressively, they gave it autonomous swarming algorithms. This allowed multiple drones to autonomously coordinate their approach vectors and perfectly overwhelm enemy defenses.
But here is the most important number on the screen, $35,000. That is the exact cost of a single, highly effective, precision-guided, and entirely expendable LUCAS drone. It is an absolute bargain in the context of modern military hardware, and it provided the Navy with cheap, overwhelming mass on a staggering scale.
And to really understand why that $35,000 price tag matters, consider the economic checkmate happening on this slide. $5 million. That is the cost of an American SM-6 interceptor, which is the kind of money we usually spend shooting down cheap enemy drones. Iran spent 40 years building an anti-access system specifically designed to drain American resources. They basically set up a defensive toll booth that charges us $5 million per intercepted asset. But the LUCAS flips that entire trap in reverse. By launching a $35,000 drone right into their defenses, we are essentially driving a cheap motorcycle straight through their expensive barrier, aggressively forcing them to burn through their finite and costly magazines just to swat away our cheap decoys. It's brilliant.
Section 5. Operation Epic Fury.
So let's look at how this actually played out. The offensive kill chain during the operation was just an absolute masterclass in modern synchronization. You had the Littoral Combat Ships zipping around at over 40 knots in the shallow waters, deploying these massive swarms of LUCAS drones. These cheap $35,000 drones immediately flooded the radar scopes of the IRGC air defense. And the beauty of it is, they didn't even have to destroy hardened targets to be effective. They just had to act as cheap mass to confidently kick the door open. They successfully blinded the enemy radars and forced them to rapidly empty their surface-to-air magazines. Then, once that defensive corridor was torn wide open, the big Arleigh Burke destroyers, sitting safely behind the LCS, fired their heavy $2 million Tomahawk cruise missiles straight through the gap to cleanly finish the job. We beautifully used expendable drones to blind the shield and heavy missiles to deliver the sword.
But while that offensive mission was tearing up the skies, an equally vital defensive mission was unfolding quietly in the dark waters below. Remember all those mines we talked about? Well, the LCS deployed a brilliant 3-layered architecture of robots to completely clear the Strait of Hormuz.
First, a remote-controlled boat called the CUSV towed a sonar array to meticulously map the seafloor from afar. Right above it, an MH-60S helicopter actively scanned the middle of the water column using an airborne laser mine detection system, or ALMDS. And the very moment a mine was found, an expendable underwater robot called the AMNS swam right up to the explosive and violently neutralized it. It was 3 layers of continuous, autonomous detection and destruction, safely allowing the LCS to clear a heavily mined strait without risking a single human sailor in the water.
The devastating results of Epic Fury basically wrote themselves across the surface of the Persian Gulf. Over 100 Iranian naval vessels were systematically destroyed, completely neutralizing the surface fleet that was supposed to overwhelm us. But honestly, there's a brilliant, poetic irony in these final results. You see, the IRGC had spent years custom building a dedicated drone carrier by welding an expensive angled flight deck onto a massive commercial cargo ship. But it never even sailed into combat. It was heavily damaged and completely broken at the pier. Meanwhile, our so-called floating garbage ship, the cracked aluminum vessel with grinding gears that Congress desperately wanted to scrap, it actually thrived as a highly effective combat drone carrier. Iran built a carrier from scratch and lost it. We took a ship everyone wanted to throw away, and it absolutely won the day.
Section 6. Math over perfect machines.
And that brings us to our final takeaway. The future does not belong to perfect machines. It belongs to imperfect machines in the right position, running the right equation. The Littoral Combat Ship was never a fundamentally good ship. We know that. But in this incredibly specific scenario, it was the exact right variable for a highly complex equation. It undeniably proved that distributed lethality isn't just some PowerPoint buzzword you hear at the Pentagon. It is a battle-proven doctrine. You don't need one perfect $13 billion platform that does everything. You need highly expendable, imperfect platforms that do one thing perfectly, deeply connected by a modern network that mathematically multiplies their effect. If you found this breakdown of strategic paradoxes in military engineering as fascinating as I did, make sure you subscribe to this channel, Conflict Explained, so you don't miss our future deep dives. Now, I leave you with this final question. In a modern age of billion-dollar defense budgets, are we spending way too much time trying to engineer elegance when we should really just be doing the math? Think about it. See you next time.